Welcome back to Geometry Chapter 9, Section 7 in this book. And we're going to talk about something that you might have already learned in science, especially if you've had physics, called vectors. So in science, there's certain things called vector quantities and scalar quantities. Vector quantities have magnitude, strength, and direction. Scalar quantities don't, which means like speed could tell you how fast you're going. That you're going 55 miles an hour. That's the speed. If I tell you that you're going 55 miles an hour northeast, I have added a direction to it, and it's not speed anymore, it's velocity. And because it has magnitude and direction. If I give you a quantity like degrees Fahrenheit, does temperature have a direction? No, never. So temperature is scalar, and speed is scalar, but velocity is vector because it has direction. So anything that has direction is a vector. Now, if you don't understand the science, that's okay. We're just learning the math today. It'll be fine. All right. Now, so how you represent a vector, a quantity that has direction too, is with an arrow. The arrow tail, how long it is, shows how strong the magnitude is. The arrow head shows the direction. A lot of times you will use the distance formula to get how that you can find out how long the tail is and what the magnitude is. And I know that's a little confusing because you use the distance formula to get the magnitude, not the direction. So just remember distance, not direction. So this formula you've already learned. You learned it in Algebra 1, maybe even pre-algebra, and earlier this year. Just remember it's x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root. We have a program for this in our calculators. If you don't have one, you should get one. Another thing about it is sometimes, like say you're doing slope, it really matters which one is x1 and x2. With the distance, it doesn't matter. If you get them flipped, you'll still get the same answer. So that's one of the things I like about the distance formula. All right, so let's talk about how this works with the vector quantity. Okay, so if we were in class, I would get my marker and I would get whichever kid is sitting right here and I would tell them, put your hand on my marker with me. And they would. And then I would say, you pull it toward you and I'll pull it toward me and let's see which way it goes. And I tell them not to do it too hard because I don't want it to break and ink to go everywhere. And we would both pull and it wouldn't go straight to me and it wouldn't go straight to the kid. It goes somewhere in the middle. So it's like the resultant is what it's called. It has two different forces that controlled it. And so like right here, this is like a person pulling the marker this way, the other person is pulling it another way, and it goes somewhere in between. So this vector, what really happened, the resultant, had two components to it. And our vector here does also. If I have it graphed up this way, it's got an x component and a y component, meaning it went over 4 and up 3. Now it didn't all at once going this way, but where it ended up was over 4, up 3. So vectors can be written in a component form of their x and y, and that's really important in physics. You break it down to x and y, you use trig, you solve for theta, you figure out about how the sign is hanging, how the kid is hanging off the monkey bars. Classic physics problems that you do with this idea that you can break vectors down into an x component and a y component. How you write it is with these little triangular brackets. They're not regular round brackets, they're triangular brackets, and it's showing that our vector went over 4, up 3, and then you draw a line from the tail of one to the head of the other one. You can only add vectors head to tail like that, where that goes tail, head, tail, head. You can't put two heads or two tails together. It doesn't work. And then you draw your line from the beginning tail to the top head. The tail is considered this end of a vector. The head is where the arrow head is. All right, this will make more sense as we look at them. Okay, so here's one. Here's another one. And we are given 2 points, 0, 0, and negative 6, 3. So it starts at the origin, it goes over here. We can use the distance formula and find out its magnitude, how long it is, and we did, and it was 6.7. And if you have the program, do it on your calculator, all right? And then we break it into its components. It went over 6 and up 3. But it didn't go forward, it went back 6. It went negative 6. So you always put x's first, then y's. What's you do back and forth first, and then up and down. So it's negative 6, 3. Here's another one. This one started at 0, 2 and ended at 5, 4, the green line. So it went over 5 up 2, over 5 up 2. I used the distance formula and got the distance as 5.4. One of the things you do with vectors is because they have magnitude and direction, that you have to tell the direction. So sometimes it's things like where you use the compass rose and you say you're traveling 55 miles an hour northeast. And this is called a compass rose, that little directional thing. And you know, I didn't know that until I was teaching physics in high school, to a high school. Like I'd never learned it in high school or college. I never learned that till I started teaching physics, and it was in the physics book I taught. And I explained it to the kids. I was like, I never knew this. And they were all like, yeah, we already knew this. I'm like, Anyway, but a lot of times with trig, you are giving directions in degrees. You know, you're going 30 degrees to the north or something like that. And so we use our trig to solve for theta, and that's our direction. So here is an example. I think the example in the book, I taught this yesterday and I haven't looked back at it, but I think it's that a ship is going this vector. It's going 25, whatever, miles per hour, knots. What do ships go? This direction. And we can break it into its x component and y component. So it's going 20 over and 15 up. And we could get theta and we would know the direction that our ship is going. So we have adjacent and opposite. So you think about all the trig formulas, which one you're going to use. Some old horse caught another horse taking oats away. We have opposite and adjacent, so ding, 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 we're going to use tangent. So the tangent of theta is opposite over adjacent, but we want to get theta, so we want to, just like how we always do the opposite to get x, we want to do the opposite of tangent, so you push the second button on your calculator, then tangent, and it'll put a little -1 there, the little inverse symbol. So why is theta not alone? Because it's got a tangent. What's the opposite of tangent? Inverse tangent. So do inverse tangent, and then put your opposite over adjacent, 15 over 20, in the parentheses and hit enter, and you can get theta is 36.9 degrees. I always think this is fun, because you get to use the fancy buttons on your calculator. All right. So vectors are considered equal if they have the same magnitude and direction. So they can't just be the same length. They also have to have the same direction. How do you add vectors? Well, this is on your test if you're taking the test with this, and it's all about the way it's written. It's just the notation. Okay, so a lot of times you'll have lowercase letters with the arrow on top, and that means vectors, and then a lot of times it's just the top part of the arrow, like that. So vector u plus vector v. And this vector the x component is -3 and the y component is 4. Is what we're going to find out. But right now, before we get that, we'll just erase that. We are told to start with that u is 3, 5, and v is -6, 1. And we want to add them together. So you can actually just draw a plus sign, draw your little equals mark, and 3 plus -6 is -3, and 5 plus -1 is 4. So vector u plus vector v is, and you write it in those little triangle brackets, -3, 4. Okay? Now, what if they sometimes say, okay, well, what if we subtract them? Well, then we can do it the same way. We write down u, this one's u, and we write down v, and we're going to subtract. 3 minus -6, 2 negatives to make a positive is +9, and 5 minus -1 is 2 negatives to make a positive. 5 plus 1 is 6. So this one, if you subtract, is 9, 6. So they'll write this little way of writing it, and then they expect you, all you have to do is do the math. You don't even have to draw it, you don't do any trig, you just do whatever it says to the x and the y separately. So, add up your x's separate from your y, your answer is x and y, put it in those little triangle brackets. Ta-da! Alright, so that's it for chapter 9. Come back and we'll do chapter 10. Geometry is great and math is great.